All right, today we're going to start taking a look at other numeration systems, and we're going to look a little bit at some flaws that are in their systems, and you will see some reasons why we don't use their systems anymore. But there are some nice things in their systems too, and we'll sort of pinpoint that along the way. So the first thing we're going to talk about is what a mathematical system is. So a mathematical system is composed of three things. You got to have a set of elements. You have to have a way to operate between them. And then you have to have a way to compare those elements. Okay? So our system has all of these things. Or we wouldn't have a mathematical system, right? So jot this down. And then we're going to jot down how our system satisfies these criteria. Okay, so our system is actually called the Hindu-Arabic numeration system. Did you know that? Might not have, but that is what it's called. So it was developed by the Hindu, and then it was perpetuated by the Arabic, and so that's our system that we use. We have the numerals 0 through 9. Those are our numerals. Those are our elements. Some of our operations are addition, subtraction, multiplication, division. There are others, but those are our four basic ones. And some of our relations are equals, less than, greater than. And again, there's more of those as well. Less than or equal to, not equal to, things like that. So our system has all these features, but it didn't just start with our system, right? God did not give Adam and Eve a Hindu-Arabic numeration system. It didn't work that way. It was developed over time through a lot of other systems coming first. So that's what we're going to be taking a look at today. There's actually two sections of material, section 4.1 and 4.2. It's really like one big giant section of material that's been split, and it's split with a purpose, the way it's split. But it is almost like just a continuation. So the first system that we're going to look at are Egyptian numeration system. The Egyptian numeration system has symbols for the numbers 1 to 10 to 1 million right here. So the symbol for the number 1 is a single line or a single stroke. The symbol for the number 5 is a heel bone. It looks like our intersection symbol from when we did in chapter 2. The symbol for the number 100, that's not very good, is a scroll. So it looks like that. All right, here's where the drawings get fun. The next symbol, the symbol for number 1000, is a lotus flower, and it looks something like that. The good news is when you get into my math lab, you're not drawing any of these. You're going to be selecting them from multiple choice kind of lists, so don't feel like you got to be an artist. It's not going to be a problem. Oddly enough, the one that I have the most difficulty drawing is the pointing finger. And it legit looks something like that, but my drawings never actually even have looking well when I draw them. 100,000, you guys saw this one when I was erasing slides earlier, is a burbo fish. And it looks something like this. Yeah. Other resources that I've taught from before don't call it a burbo fish. Some of them call it a tadpole. FYI. And then the last one is an astonished person. And for my education majors who've taken number theory, they draw this one differently. So it looks like this when this book draws it. He's excited. Yeah. I think he's excited because he's worth $1 million. Can you see him? Can you see the person in there? He's going like this. All right? You see his legs? Yeah. That is how it's drawn in my math lab, pretty close anyway. So we're going to do two things. Actually, we're going to do 4 things with the Egyptians. The first thing we're going to do is we're going to take numbers that are their numbers and figure out what they are in our system. Then we're going to take numbers that are in our system and write it in their system. Okay? And then we're going to add and subtract. And you're going to see that their addition and subtraction actually looks an awful lot like ours, which is interesting because this is a long time ago, right? It's a long time ago for there to be such similarities. Okay, did everybody get a picture of this if you didn't finish writing it down? All right. So these are not written into your notes because I don't have a good way to draw them in there inside of like Microsoft Word. So go ahead and take a minute and draw them. You can see my pointing finger at the beginning there looking terrible, right? Got a couple lotus flowers, a couple heel bones, and so forth. So draw those in for 1 and 2. And then we're going to turn their number into our number. Okay, now what we're going to do as we draw these out, you may not need to write all the things down that I'm writing down. That's fine. I'm going to probably overwrite a little bit in this chapter. But I want to make sure that everybody gets what they need to, so that's why I'm going to do that. We're going to write down what each of these values is. So the pointing finger is worth how much? It's worth 10,000, and there's one of them, so it is actually worth 10,000. So I'm going to write down 10,000. The lotus flower, how much is a lotus flower worth? It's worth 1,000, and there's 2 of them, so you think it's probably worth 2,000. You got it. So this one's 2,000. How much is heel bone worth? It's worth 10, and there's 2 of them, so it's actually 20. And then I have 3 strokes, so I have 3. And then I put them all together, right? So this is 10,000 and 2,000. That's 12,000. And then 23. Is that good? Okay. Second example. We have 3 burbo fish. How much is a burbo fish worth? 100,000, and there's 3. So there's 300,000 here. Then I have 3 scrolls. How much is a scroll worth? 100, and there's 3, so it's 300. 4 heel bones. How much is that? They're 10s, and so I've got 4 of them, making a total of 40. And then I have the 2 strokes at the end for a 2. And again, I'm going to put this all together. I have 300,342. Okay, their system is not difficult. It isn't. It's repetition of symbols. There's very few structural differences that make it feel like you're working with something that's very strange. We're going to have some of that in other systems, so I'm mentioning it right now for you to have some appreciation for the Egyptians and the simplicity of what theirs is. So we're going to go the other direction now. We're going to start out with one of our numerals and put it into their form. And we're just going to go place value at a time. So the 2 is in the 10,000s place. What symbol is worth 10,000? Pointing finger. So I'm going to draw 2 pointing fingers. Told you how terrible they look. They just get worse all the time. My 2 pointing fingers. Then we have the 3 that's in thousands place. What's that one? Lotus flower. So I need 3 lotus flowers. The 1 in the hundreds place, so that's 1, what? Scroll. 4 in the tens place, 4 heel bones. You can write 4 heel bones left to right. You might also see them depending on how many there are stacked. Usually if there's more than 3, they start to stack things. So you'll see them stacked, and a couple of our systems do that. And then the last one is 5 strokes. So I have 3, 4, 5, like that.
Could you tally mark them?
Nope, they do not tally mark it, so you can't either. That is annoying.
That's crazy.
Yeah, no tally marks, okay? So as we work in our systems today, there's going to be one in particular going to be like, I don't like the way they did that at all. I would have changed that, and you don't get to.
Just one.
Right? It's going to come into play with Which system is it? Oh, it's going to be it's the Roman numerals. We're getting there really quick. You're not going to like something that they do. Okay, next one. 51,300. The 5 is in the 10,000s place. What is that? 5 pointing fingers. So we need to stack them. At least we don't have to, but we will. Okay. One what? One lotus flower. The three scrolls. Okay. Is that all right? Okay. Now we're going to talk about addition and subtraction. This is the only system where we're going to look at addition and subtraction. And we're looking at it for really the purpose of recognizing that it's so similar to what we do. So what we do goes all the way back to the Egyptians, right? Pharaoh, Moses, all of them. Yeah? Yeah. Okay. Adding Egyptian numerals, much like ours. We line up the same symbol. Sometimes we need to carry through regrouping, and we work from right to left. Okay, can I switch to another screen? Pretty close. All right, it's not written into your notes again, so write it in. You will see that they are lined up like it already described, right? The symbols on top match the symbols that are underneath them and so on. Now, the goal is not to turn each of these symbols into our system and then subtract them and then turn them back into their system. That said, it's not that you can't do that. You could. It's just a lot more work, and it's not really the spirit behind the question. The spirit behind the question is to recognize how similar it really is to our system and how we do things. So it told us we're going to work from the right to the left. So we're going to start on the right-hand side with the strokes. And you're going to count how many total strokes there are. And how many are there?
6.
There are 6. So we're going to write down 6 of them below, and we'll stack them. So 3 and 3. 6 strokes. How many total heel bones are there? 11. That's too many. Anytime we have more than 9, it's too many. Because what could I do with 10 of those heel bones?
Scroll.
I could turn them into a scroll. Now, it's kind of like what we do with money. If you had 10 $10 bills, you could turn it into a $100 bill, right? We do this. So we do it in our regular addition and subtraction as well, by the way, right? We would not write a number 11 in a single place value spot. We'd write a 1 and we would carry a 1, wouldn't we? So this is what we do. So I'm going to draw it like this. Here's 10 of these guys. They're going to become an additional scroll. And I have 1 of the heel bones that didn't get grouped in the 10 that's left over to write down. And then how many scrolls do I have? 2. And the last part of these directions say to turn this number, the final answer, into our number. What is that? 216. Are we good with that? 216 at the end. Okay? Subtraction's quite similar. Much like ours, we're going to use regrouping, and we borrow when necessary. Okay, so this is what we're writing down now. Lots of symbols, I know.
We do the scroll backwards. Okay.
Well, it doesn't really matter because you're going to be choosing from a multiple choice option.
That's true.
So, in some sense, no. And in a broader sense, they weren't really particular in this particular numeration system about how they drew them. So I actually have seen them drawn in different ways, and it still would count as a scroll. Not sure why they did that way, but that is something that was used. Okay, so again, like our system, we're starting on the right-hand side and moving to the left. We're starting with the strokes. On the top, how many strokes are in the top number? 7. And how many are in the bottom number? 3. So if I have 7 strokes and I take away 3 strokes, I've got 4 left. You could write them stacked if you wish. But I run into a problem in the second one. Because how many heel bones are there in the top number? 3. And how many heel bones are there in the bottom number? 7. So I can't have 3 and take 7 away of it, right? Like that's not possible. So what we do is we do like we did on the last problem in reverse. I take one of my scrolls and I turn it into 10 heel bones. So I no longer have 3 heel bones in the top number. I have 13. There are 13 of them up here. So now that I have 13, I really can take away 7. How many will I be left with? 6. Make sense? Okay, take a look at the scrolls now. How many do I have left of the scrolls? 4. And I'm going to take away the 2 that are below, right? There's 4 left on top. Everybody read? We took one of them away. So there's 4 left on top. And we've got 2 on the bottom to take away. So how many scrolls will I be left with if I remove them? 2 scrolls. And then my lonely little lotus flower doesn't have anything to remove it, so it just comes down below as well. What is this number? 1,264. Now, take caution. Because they don't have any need for it, really, there is no 0. So, in theory, we could have seen a question that didn't have the lotus flower at the front here. It had a burbo fish, right? So when we write it in our system, we need to recognize that the burbo fish has a specific value. It's not just the next number over in our system. Okay, so pay attention. Same thing if we had to borrow. What if there had not been any scrolls here? Like there's just no scrolls in the top number at all. I'd have had to go over to the lotus flower, and I would have had to have the lotus flower turn into 10 scrolls. And then I could have taken one of the scrolls and I could have turned it into the 10 heel bones, right? So this is exactly what we do in our system. When there's nothing to borrow from, we go over another place value, and we go over another place value, right? They do that as well. All right, ready to look at the Romans? Okay, where do you see Roman numerals used even today? Super Bowl. That was my first answer in my other class too, by the way. Super Bowl. What's that? Tattoos. You know what? A young lady in my last class had a tattoo. I saw it after I'd already passed the Roman numerals. I would have said something. Okay, what else?
Clocks.
Clocks. Did you know Rayleigh Chapel has Roman numerals on it? And your assignment, if you choose to accept it, is to take a look at Rayleigh clock and tell me what's wrong when you come back. If you already know, keep your mouth shut. Don't spoil it for your classmates. There is something wrong with it. You need to be quiet. It has nothing to do with hands. What'd you say, hands?
Like the clock hands?
No, it's nothing about the clock hands. No more guesses, though. Okay, there is something wrong with Rayleigh Chapel clock.
Was it the tornado or was it just always like
No,
this?
it's always been like this.
So we gotta climb up to the...
No, you'll be able to see it
That's
from the
not
bottom.
me.
You'll be able to see the
That's
bottom.
what I heard.
Where else? Come back. Come back with me. Where else do you see them used? Roman numerals.
books.
Books, yeah. And what'd you say? You say books as well? Books. Chapter headers in books a lot of times as well. How about outlines? Do you see anybody teach with outlines? And they use Roman numerals? There's another one, too, that you probably wouldn't be aware of because of where we live. If I was teaching this class and we were in Washington, D.C., you'd have this as an example. Buildings have established dates. A lot of times in Roman numerals, if they're old enough anyway. We aren't old enough in Oklahoma to do this. I mean, not the people, but the state, right? We don't have those kinds of things here. My brother-in-law got married in the Washington, D.C. area, and the church that he got married in had it on the door that it was established at a certain year. I don't know what the year was, but so there's some other things too. At Tombstones, that church had a cemetery behind it, and the tombstones had the dates in Roman numerals. So, never know. All right, Roman numerals. You know some of them. What's the first one? It's an I. You're welcome to write it as a single stroke, or you're welcome to write it as lines on the top, either way. How about the 5? V. 10?
X.
Okay. After that, it gets harder because we don't use them as much. 50 is not C.
L.
It's an L, but 100 is a C.
C.
Do you know? It is D. 500 is D, and it's M. Very good. Samuel's got these down, man. Okay. Okay, excellent. All right, so these are our symbols, but they don't just do like the Egyptians did and repeat them a whole bunch of times. You know this because you know some of these numbers. They don't do it that way. And so they have 2 properties in particular that we're going to focus in on. Whoops. Yeah, it's a lot of writing on this slide. Property number 1, so in terms of your notes, if you're thinking about space, the way I've got mine is I've got my numbers on the left and I've got all the properties on the right. I just can't fit it on a slide that way. They do some repetition of symbols. If they need the number 3, they do 3 I's. I mean, that's what they do. Okay, just find a blank space. I have my blank space beside it on my paper. But they don't repeat too many times. In particular, 3 is the maximum number of times they will repeat any symbol. So anytime you might need something to repeat more than that, they do something different. In particular, that's the subtraction feature for unique situations. And I've written them all down. All of these are the unique situations. The I can come before a V or an X. It can't come before anything else, just before V's and X's. IV is the number 4, and IX is the number 9. The number X can come before an L or a C, not before anything else bigger than it, just the X and the C, the L and the C. XL is the number 40, and XC is the number 90. And the C can come before a D or an M. CD is the number 400, and CM is the number 900. So in particular, what have they done? Well, in all 6 of these cases, they've put a smaller symbol in front of a larger one. And that's when we know we have a subtraction feature. Smaller symbol in front of a larger one. But you can't just put any smaller symbol in front of any larger symbol because they didn't do it that way. So we can't change their system and do it that way either. Okay? Now, I've given you all cases, so you could just go back to these every time you want, right? And notice, which one's which. That's fine. But take a look as well. What numbers, as in our numbers, are present in every single one of these? What numbers are repeated? 4s and 9s. It only affects 4s and 9s. Why? Well, if I had the number 4, I'd actually have to do 4 symbols, right? But they don't do more than 3 symbols. Same thing if I had the number 9, I could do like the number 9 itself would be, if I was allowed, would have a 5, that's the V, and I'd have 4 1s. But I can't have 4 1s. I'm not allowed to repeat things that many times. So they have the subtraction feature. Second feature that they have is the multiplication feature. So you might have noticed, and if you didn't, now I'll make you aware of it. 1,000 is not very big compared to the fact that the Egyptians went up to 1,000,000, right? So what do we do if the number's bigger? Well, this is what they do. They have a multiplication feature. So if the number is bigger than 3,000, and the reason I say 3,000 is because if I had 3,000, I could just write it as 3 M's, right? But if I had 4,000, and I'm not allowed to write the number 4 times, the number M 4 times, I got to do something different. So if the number is bigger than 4,000, what they would do is that they would write whatever the symbol was, and they'd put a bar on it, and that bar on top means times 1,000. If it was big enough, they'd put a double bar on top of it, and it means times 1,000,000. So this is how we get bigger numbers, which we don't see used very much today. That isn't to say that they didn't use them. We just don't see them as much in the way that we use Roman numerals.
What does the bar look like? Just like writing literally a line above the letter?
Yeah, so like if you had 5,000, it would be a V with a bar on the top.
Okay.
Literally like that. It doesn't look like the bars that we sometimes put, like when you think about it in books, where they're attached. It is separated from it. Yep. Okay, you ready to do a couple examples? Okay, everything else that we do today is going to be like this. We're going to take their numbers and turn them into our numbers. We're going to take our numbers and turn them into their numbers. No more adding and subtracting. The first one, 7, is actually in your notes, I think, but I think you're going to have to write the number 8 in because of the bars on the top. I don't have a good way of drawing that very well inside of Word. So the first one, MDXCVII. So again, this may be overkill for you based on your exposure, and if so, then just don't worry about writing it all down, but I'm going to write it all down. I'm going to write down each of the numbers that are present here. So M is the number 1,000. D is the number 500. X is 10. Yeah. C is 100. Audience participation time. V is 5. And then the II is 2. All right. Do you see any locations where a smaller number is in front of a larger number?
X and C.
Yep. So you could either notice it here, which is fine, and go over the list and recognize, oh, look, XC is going to be 90. Right, that's fine. You can do it that way. Or you can recognize it down here and say, oh, look, there's a 10 in front of a 100. I'm going to subtract there. Now I'm going to get 90. Either of those are fine. Regardless, I have 90 here. And then I'm going to put the numbers all together. So I have 1,000, 500. That's not right. 900 is what I meant to say. No, it was right. 500 and then 90. There's my 9. 90 what? 7. I have a 5 and a 2, so I have 7. And that actually does kind of look like a date that you could see on a building or close. Okay. Let's try the other one. We've got bars. What we can do is we can actually put in sort of like separation bars between where our bars that are on top of things are. So notice my X has a double bar on top of it. It's the only thing that has a double bar, so I've kind of drawn a separation bar there. CD has a single bar on top of it, and then there's no bar on top of the rest. Okay, so how much is X generally worth? 10. But what's it going to be worth with the double bar on the top? 10 million. So X is now worth 10 million. Yeah?
Because each bar is basically 3 zeros, is that?
It's not 3 zeros, but you can think of it that way. It's almost like where we put our commas. There's definitely some overlap in how we feel, like intuitively feel about that. Yeah. CD. What's C? 100 and D? So 100 in front of a 500 would be 400. It's subtraction, right? 400. But it's times 1,000, right? So it's 400,000. And I'm kind of out of space, so I'm going to shift the other part over here just so I have more space to write it out. LXIV. How much is the L worth? 50. X, 10. I, 1. And then V, 5. Do you see subtraction here? Yeah, at the end here, this is the number 4. You probably even saw it before I wrote down the 1 and the 5, and if that's so, that's great. But I don't write down 50 and 10 when I've actually put them all together, right? The 50 and the 10 get added together. So I have 10,400,000, what? 64. So it's a 0, 6, and then 4. Okay. Ready? Other direction. Now we're going to take their numbers, our numbers, and write them in their numbers. How do I get 2,000? MM. How do I get 800?
Can we subtract 2 tens from a C?
You do not.
D, C, C, C.
Okay. D is 500, 600, 700, 800.
Nice.
Yeah. We write things 3 times. No subtraction of 2 things in front.
Because you can only do subtraction with the ones that we give.
Yep.
Oh, okay.
Only do subtraction with 4s and 9s. And notice 2,861 has no 4s or 9s, right? We will not have any subtraction features on this one. How do I get 60?
LX.
Okay, so L is 50 and X is 10, so that's 60. And then I have an I for the 1 at the end. Number 10. Do we have some 9s? We have 3 of them. And while I wish I could tell you that we could just put an I in front of a M, because M's 1,000, and just take one away to get you 999, you can't. Because they didn't do it that way. We don't get to change it. Yeah? Okay. Let's start with the 7 million, though. So in a very much the same way of separation, like I was doing with some of the other things, we're going to separate, and we're separating at the commas. So, because that's the millions place, and then that's the thousands place, is why. So how do I get the number 7? Just plain old 7. Yeah, V-I-I. How do I make it million? Double bar. Okay, how do I get 300? CCC. But how do I make it 300,000 with a single bar? 999, and I cannot subtract 1 from 1,000.
Would it just do CM, XC, IX?
Yep, so we're going to do 900, we're going to do 90, and we're going to do 9. That's what we're legit going to do, like place value at a time. I get 9, and these are all on that list that I gave you over here. All right, how do I get 900? CM. How do I get 90? XC. And how do I get 9? IX. And we all still wish we could do IM, right? Yeah, it'd be nice, but they didn't do it that way. Okay. You ready for the last one in this section? This one's the most fun to write. You just thought the last ones were fun. Whoops, the right one. This is traditional Chinese. So they have a lot of symbols. Like, this is more than any of the other systems we've had so far. I've got 1 through 10, and then I've got 100 and 1,000 and a 0. That's the first time we've seen that. First time we've seen a 0. Notice the notations on the right-hand side as well that talk a little bit about how they write their system. They use positional numeration in a multiplicative grouping manner. I'll talk about what that means, but just jot it down. And they write things vertically with the larger value on top of smaller values. So their numbers are written vertically, not horizontally. And we're going to talk through what each of these symbols looks like. The symbol for 1 looks like just a short horizontal bar. A little bit of an angle to it if you wish, but whatever. The number 2 is that they're stacked with a smaller bar on top of a larger or longer bar. And the number 3 looks like the penmanship paper that you used when you first learned to write. All right, 3 bars with the line in the middle. 4. 4 looks like curtains to me. 5 either looks like an H, that's what I think it mostly looks like, or a chair. It's got a bar on the top and a bar on the bottom of it. 6 looks like a stick figure without a head. 7 looks like a lazy T. It's almost like it's laying down a little bit. 8 actually looks like the Greek letter lambda. The lowercase lambda. 9 looks like a lowercase n. That one is nice.
For 9.
Yeah, n for 9. 10 is a plus sign. 100, in fact, does look like dynamite. Right? Think Wile E. Coyote and the Roadrunner, right? Cartoons kind of stuff. Yep. 1,000 looks like the plus sign with an extra little line on top. It's a little bit wider there. Let me try to draw it a little bit better. Like that. And for 0, I actually have to change my pen stroke to be smaller to even write it. 0 is the most interesting one to write. So you're going to draw kind of a curled line up there and draw a line down. You're going to draw it like it's, I don't know, a lampstand or something. And then you're going to put what looks like a little lowercase p underneath. Then you're going to draw 3 lines through the middle. Yeah. We won't write them very often. Okay? Cool. The zeros are used when they're trapped between things. So I'll make sure I show you what that means. But that is when they're used. Okay, so let's do an example. And by example, it will explain what is meant by they use a positional numeration in a multiplicative grouping manner. Okay, the pattern will actually show up there. Did you get it on the picture? Okay, let me put it back. So sorry. Let me slow down. Anybody else need a picture too? You got it? Okay, cool. And of course, these are posted later, so if you need to go back and see something on a video, they're posted in Canvas. Okay, we're just going to write the numbers down like we have been doing for the Romans and the Egyptians and everything anyway. What's an N? 9. What's dynamite? 100. 3 lines. Plus sign. H. Perfect. Okay, pretty good? Do you notice how it looks like it's alternating? I've got a single digit number and then I've got a 100. And then I have a single digit number and then I've got a 10. And then I end with a single digit number. Do you see that? Okay, here's what they do. They group these together and they group these together and the groups get multiplied. Now, they don't just randomly group anything together. It's always powers of 10. Namely, it's going to be the 10, the 100, 1,000. Those are the only things that are going to get grouped like this. Okay? So, when I have the 9 with the dynamite after it, that's actually the number 900. And the 3 with the plus sign after it, that's actually the number 30. And I have the 5. We don't do this exactly, but we do this. Right? If you talk about the number 432, the 4 at the beginning is not really a 4, it's 400. We have a positional system. Its position gives it value. And that's what you're seeing here too. The position gives it value. It's just that it has to be positioned beside the 100 or the 1,000 or the 10. And then we're going to add the values together. So we have 935 as our final answer. So far, so good? Okay, let's write them out for the next one as well. Curtains. 4. We have the plus with the extra line on the top. That's 1,000. 2 lines. And dynamite. 100. Okay, group them together. Right? The single digit with the number that comes after that's a power of 10. So 4 and 1,000 would give me 4,000. And 2 and 100 would give me 200. And my total ends up being 4,200. Notice what we didn't have. Zeros. There's no zeros. The zeros are trailing, right? The 0, 0 at the end in the hundreds place is 0, 0 there. So we don't see them use zeros there. Ready for the next one? Okay. Now we're going to take our numbers and write them in Chinese. How do I get a 2? 2 lines, and then I need it to be 100 after it, so I need the dynamite. That's how I make 200. Now, it'd actually be really nice to just move on past the 0, but it is a trapped 0, so we're going to write it. So here's our 0. Our line, like so. There's my 0. But the 0 is in what place value? Tens. So I write a 10 after it. 0 times 10. And then I need another 2. 2 lines.
And they would read these vertically.
They would read them vertically. Yeah. This is traditional Chinese numeration. You will see it still used in some of their literature today. But not in like computational mathematics. Computational mathematics is very standardized with our Hindu-Arabic system. Okay, next one. How do we get a 7? Lazy T. But it's supposed to be 7,000, so I need plus sign with a hat. 6. Yeah, the stick man with no head. But it's supposed to be 600. Dynamite. How about the 1? The single line, and then it's in the tens place, so you do a plus. So notice that I still have to write the 1, right? I'm going to write the 1 times the 10. The 10 can't stand alone. It has to be multiplied by something. In this case, it's multiplied by the 1. So that's a nuance to that. And then I have my number 2 at the end, much like I had before.